Okay, welcome to my talk, Event Source Microservices with Play and Akka. I actually gave this talk at the Box Days Vienna in March, so a few things have changed since then, but I haven't updated the talk, but the main information should still be valid. A little bit about me. My name is Dominik. I am a freelance software engineer. I'm leader of the Java Vienna meetup, and I also created the Play Framework Vienna meetup. So there are some stickers around here if you want to stick them on your laptop. In my opinion, they look quite cool, and you can get rid of them anytime without leaving any traces. I mean, sure of that when you order them. I'm also a Play Framework integrator. What that means is that basically I would have commit rights on the Play Framework repository, but everything there is working with pull requests, so I cannot just put a Trojan horse there like this young lady does. And yeah, usually I'm working with Java, with Scala, when I can with Akka and Spark. I love the Play Framework. The systems I'm using Cassandra and Postgres, and I also like the streaming technologies that are based on Akka. Yeah, about this talk, what will it be about, or how it is structured. First, we will have a quick introduction to event sourcing. Then I will give a short introduction to actors and actors in Akka. Probably most of you already know Akka, so we can skip the most stuff. Then I will show about event sourcing with Akka persistence. I will give a short introduction to CQRS. I will show how you can do clustering with Akka. And I will show you some personal tips on how I structure my code base and my dev environment, so it's I have a seamless developer experience. Yeah. Okay. If you have any time questions, please just raise your hand and ask me. As I will assume that it's too boring and you already fall asleep. Okay. Event sourcing, a few reasons and an example. We give a short overview, what are commands and events, what is the journal, and what is a command handler and an event handler. So why would you do event sourcing? Basically, you can do high performance computing with it. You have immutable events, so Oleg called them final objects, or how you said about them? Constant objects, yeah, I call them immutable. Usually you have a append-only journal, or you can have multiple journals, it's depending on the technology you use. And because everything is immutable and it's just append-only, you have very high write performance because you don't have to do any logging. The other cool thing is that you don't need any object relational mapper, so you don't need Hibernate or Eclipse Link or anything like that. And you always have a full audit trail. So all the time, every time you can really figure out how the current state of my object, what events led to this state. This is particularly useful in the topic, also in the area of the GDPR, where you should have always this audit trail. On YouTube, someone mentioned that this is also a problem, and I will also give you a possible solution, like how to do this. Together with this full audit trail, you also get a great feature, namely that you can debug your application, that you can roll back to any point in time and see how was my application at, I don't know, 5 months ago on the 3rd of May, on the 3rd Monday at 5 p.m. Stuff like that. What are typical examples of event sourcing? Your bank statement or your PayPal account. There you usually have like the rows in your bank statements. They are just basically events that say, okay, from this person or from this account, this amount of money came in or this amount of money went out, and this is the description and this is the date and so on. All those things are events. And the balance line on your account statement, that's just the aggregation of the events played from basically the beginning. What could also be an example? Git because there you also have a lot of events. Every commit is basically an event. Git has this special behavior that you can basically rewrite the history. So it's kind of event sourcing, but not in the manner that we usually have it in event source applications. If you're using if you order stuff online, like say from Amazon, or the woman like my wife, they always order from Zalando. You also always get tracking URLs, and if you open these tracking URLs, you also see a list of events that happen. And it's not just a statement, this package is now here, it's saying, yeah, it left the warehouse of Amazon on this date, and then it moved to this place, and so on. That's also an example. The blockchain, it's basically the best example of event sourcing, because there you really have a journal that you cannot change later. Yeah, and your normal good database, not MySQL or something, but like Postgres, Oracle, and so on, they have a transaction log that's behind the covers also event sourcing. But there you don't have the meaning. What meaning is, I will come explain in a second. Okay, so how does event sourcing usually look like? We have an example application where someone can register himself on a website. So what is happening? The user is opening a website and is filling out a form. Okay, and when he presses submit, this form is submitted to the web server. And usually you think of this like, okay, you have a bunch of fields like first name, surname, and so on. But you could also treat this as an event. And the event that you basically have, or the data type, is the registration data. And what does the web server do? The web server takes this data and then routes it to the appropriate controller. And from there, what you can do if you're doing event sourcing is that you take this data that has no real meaning into a registration command. So in event sourcing, it's always about events and commands. Events are stuff that happened in the past, and commands are things that you want the system to do. So your controller is basically creating a register command, and this command is then sent to a command handler. And in the command handler, you basically check the command for validity, like you check is the email address really the email address. Of course you can do this in the controller also, but in the command handler of course you should do it as well. You can check, does this user already exist, and so on. And if the command handler thinks that this command is valid, what you then do is that you persist it to the journal. The journal is this data structure which is append only, and the command handler is creating an event out of the command. Is this clear so far? Awesome. Good. So we take the command, we create an event out of it, and we put it into the journal. And as soon as we got basically the acknowledgement of the journal, what we then do is we propagate this event to various event handlers. And those other event handlers, they can do all kinds of things for us. They could say, they could send the user a welcome email. They could create an account in our LDAP system. They could, whatever here, yeah, those are my two examples. And what of course they also do is basically communicating back to the controller, hey, this is the result of your command. And from there on, it's going back to the user and he will get his nice successful registration message. Yeah, commands and events. So like I already said, the command is something a user wants us to do. Like I want to register, or I want to change my email address, I want to change my name, I want to change my birthday, whatever. And an event is something that happened in the past. It's the result of a command, and you cannot change it. It's a fact. Like it's the same fact that yesterday it was the 3rd of June, and it had like 28 degrees or something like that. You cannot change the past, and we're not in Back to the Future, so you cannot change it. And when you're doing event sourcing, what you usually do is that you have this verb here, or like register or change. And usually you name your commands that the verb is first, and then the subject is like the second part of the name. And when you create names for your events, you first have the subject and then the verb. Like user registered, or the name has changed. Depending on how big your application is and how you like to create a system, you also can append like register user command or user registered event, like the type of the object, but that's fully up to your personal preference. The event journal, it's the single source of truth. So you don't look in any elder database, you don't look up any web service. The journal is the only place where you should really look up if you wanna verify an event, command. Because that's the only place where all the facts about the past are stored. Nowadays, I mean, Wikipedia is a bad example, but if you want to know something about the past, you look into a book or something, or in a register, and the journal is something like that, but no one can change it. It stores all the events, and what it does, it's grouping the events by something called the entity ID. And it also has a sequence number for every entity. And I will show you now how this could look like. So imagine the journal as a simple database table. Okay? What does this database table do? It has a column that's called entity ID. And in this entity ID, you basically create a key for this kind of entity, like user. And then you have a sequence number. So events that correspond then to the same entity, like to the same user, they have the same entity ID, but the sequence number is going up. So what's happening behind the scenes when your event source system starts up is like, okay, I need to look up the user with ID 1, and you do a select asterisk from event journal where entity ID is user 1 ordered by sequence. And then you get all the entities, the events in the correct order. And then you can just replay them. What do we also have? We have a type. This type is used to basically map the payload. The payload we have here, in this example it could be JSON. What's happening often in Akka persistence is that you store the payload using protobuf, Google protocol buffers, and because depending on the implementation you don't know what kind of event this is before, so that's why you have the type in column here. Okay? So what you're doing is you load the payload from the database, you take the type, and from there on you say, okay, I'm creating this kind of Scala object from this JavaScript payload. What does the command handler do? Basically it's enforcing constraints. For example, you could have in most user databases, you have a constraint that an email address may only be used once. And that's what the command handler does. So basically, it, in the simplest case, it has here a vector of string, and when he receives a new command of type register user with this email and this name, he just looks, okay, is this email address already in my vector? And if yes, then I throw the exception, and if not, I'm registering the user. Okay? What it also does is that it's persisting the events that get created from the commands into the journal before it's doing anything else. So you see here, okay, if the email that the user tries to register with, it's not already registered in our system, then we are going to persist to the event journal. And what we have here is we have actually now the pointer of the thing. Does it have, I think it's next to you. Does it have a laser? Yes. Perfect. So what you see here is we have here the command, and here we have the event. And basically we're just passing this this instance of a case class to this persist to journal method, and it's getting stored into the journal. And when we get back, basically this method body gets invoked as soon as the journal tells us, okay, I stored this really in the database, and then I could either invoke other event handlers, or if I have a small application, I can just send a record. Yeah?
Sorry, just 5 days into Scala, what's a case class?
Oh, a case class?
Yeah.
A case class is basically, do you know what's a pocho? Yeah, a case class is basically a pocho that is immutable, and you all automatically have a getter method, a way like, it's not really a getter, but like public fields, and you also have copy constructors. So it's an immutable data structure, we could say, that's way more convenient to write to use than the Java thing. And in Java, I think 10 or 11, they will create the data classes that are somehow similar. I'm not sure yet how they will do it, but well, we have this since years and it's working awesome. So. Okay, so after the event is persisted to the journal, we can invoke all kinds.
Just one question. We used the CQRS pattern a lot in the last months. That registered mails or registered emails exists. Is this a data structure that is derived in the read model, or is it somehow stored in the aggregate, so the list of existing emails? Because we had exactly an issue with that kind of checks. So when you use it, this checks from the projected read model, you have of course eventual consistency. And did you have experience, and how did you solve this kind of issue? Did I express it?
So I'm just trying to reframe it. Actually, how good is the camera? Can we hear what she asked? Like this? Okay. The problem is, if this thing is really growing big, like in the aggregate, you're more or less storing the information like twice. Mm-hmm. And what I usually do is that I'm not storing events here in the aggregate, but I'm storing snapshots. And if at one point I need to recreate it, I just drop the snapshots and let it populate from the children, basically. Because the snapshots I can always throw away. Of course, and what I do is that the aggregate, it stays alive quite long. So it's basically in memory all the time. If it's getting too big, you have to find other ways to store this information. Like there's a library where you can basically store maps of heap, and then it's not a problem.
But basically, you don't access the derived read model from the command handler. Is it correct?
You mean like this is like now the aggregate?
Yeah.
And in the user, I would not access the user.
For example, if the user is a derived read model from the aggregate. So you normally have an aggregate,
Yes.
that's the write model,
Yeah.
and you have a read model, and it's derived from the replay or from the event stream.
Mm-hmm.
Yeah, where you can do your fancy query stuff, and
Yeah.
because normally the write model cannot be queried.
Yeah.
So basically, the interesting part here is where is this registered emails filled and stored? Because when you have all the emails in your aggregate that have ever been registered, yeah, you have exactly the issue. It grows too big at some time, and when you store it in a separate database, yeah, you have to you have to check if it's consistent, because when you derive the registered emails from the user registered event, and you get two commands, register user with the same email address in a very short period of time, and the read model is not updated yet, it can happen that this simply doesn't fail because you have two email addresses in your aggregate. Do you know?
I know what you mean, and I will come to this in a later part of the presentation, and I think it's a better place to discuss it then.
Okay, fine.
So, yeah. What the command handler can also do is he can delegate the event handling after persisting to the show node to other event handlers. For example, I could say, okay, maybe the send welcome email I implement in the command handler for any reason, yeah, maybe I'm lazy or something, but I can also tell it to the other event handlers. Event handlers, they are working on events from the past. In our example, the component that we have, the actor that we have, it's a command handler and an event handler at the same time. So if we look back, we have here this persist to show node, and we have a list of event handlers. And one event handler we have is one instance of the event handlers is the object itself. Why? Because in the event handler we are populating this vector of registered emails. Okay? So we have this persistent actor, it is a command handler and an event handler. The command handler validates checks and validates the command, and then informs all the event handlers, including itself. And then the event handler takes the action that's supposed to happen on the event that got generated. Okay? Good. Questions so far? Again, I will come to the other point later. Okay. Short question. Who knows already about, or better question, who doesn't know about Akka? Don't be shy, please. 1, 2, 3, 4, 5. Awesome. Okay. Good. Then we will have this short introduction to Akkas, and because they are somehow alike, we have, you know, the actors that are in the movies, and actors here are somehow similar. Yeah? So, and I compare them to humans. So, actors, in Akka, they have a state. So you can have all kind of variables. As we've seen, you can have lists, vectors, and so on. We humans, we have properties. Yeah, I'm not very tall, but I still have a height and a weight and some knowledge. Actors, they only communicate via messages. So if you want, if actor A wants to tell actor B something, he should write a message and put it in an envelope and basically send it. We humans, we communicate via voice, via SMS, via letters, sometimes via looks or touch. If you abstract it away, everything is also a message. I mean, except maybe touching, but the others are also kind of a message. Actors in Akka, they live in something called an actor system. We humans, at least the ones I know of, they live on planet Earth. Yeah, how do we create actors and humans? Actor system gets created like this. We just instantiated this new actor system. Depending on which religion you believe, God created Earth, so God does create planet Earth. How do we create a new actor? In Akka we do actor off, and then we provide a special object called props. God just made Eve out of Adam, or the other way around, depending on who you believe. And how do we make children? In Akka, you just say context and then dot child off, and you also give it like this props object. It's not really easy to translate this directly to humans because you have somewhere the part where Adam is needed, but in the end it's just Eve dot fork, right? Yeah, getting information on the example of a soccer game. To get information from an actor, you need to tell him a message, or maybe it's sending a message, but in Akka it's called tell. Like, yeah, it's maybe for some people it's easier to follow. And if we have this soccer game, what we do is I ask maybe I'm now here at the Scala meetup and my friend is at home and is watching soccer, and I say, hey Bruno, what's the current score? So score of the game, and I say I send him the message get current score. Actually, I made here a good example, so I'm just reading that. So actor he needs to send a message, and I have to shout to my friend what's the current score of the game. To answer someone in Akka, you have this reference to the person who sent you the message. It's like if you have your envelope and on the back you write your name and address. That's basically the reference, and then you just tell him, okay, this is the information you want. Or if you don't like the person, you don't answer at all. And in reality, I just shout, hey, the score is this. Yeah?
Just a question, the sender, is that actually an attribute of the get current score?
No, it's something that is provided in this context that an actor is living.
But is it part of the message?
No, it's not. It's a part of the actor. I mean, it's a method in the actor. And basically, what the special thing about an actor is that it's only processing one message at a time. So if you get 5 letters, you take the first letter, you look at the back who sent me this letter, then you put this in the sender. Then you open it, read it, and then you decide should I answer this person or not. And if you decide to answer it, you take this address that you stored in the sender and you send a letter back.
Like a context object.
Exactly, it's a context object for this particular message. In Akka type, this will change. I mean, like we heard last time with Heiko, but till that's final, that's the concept. This is all about untyped actors. Yeah, so actors in Akka. Thankfully I'm here at the Scala meetup, so I don't have to make this in Java. How do we create basically an actor? Create is the wrong word. How do we define an actor in Scala, in Akka? Basically, we create a class that is extending Akka actor. And the only important method that we need to implement in this actor is the receive method. And the receive method is basically a partial function from any to unit. So it's taking any kind of object and it's not returning anything. But of course it can invoke methods like tell the other actor, send a message to another actor, or create a child or something like that. So basically we have here an example. We have the actor type of human. And what we usually do when there's a new human, we cannot influence what's the gender of the human, but we can give it a name. So that's what we're doing here. We send a message of type give name to this actor. Here we then have pattern matching, and basically if the message is of type give name, what we do is we just store the name here in this variable, and we can do nothing, or we can answer to the person who, to the actor who sent us this message, basically, hi, I'm Dominik, or in our example, Akka. Is this clear so far? Awesome. Persistent actors. Persistent actors is basically the implementation of event. Persistent actors are actors that can have state that persists over JVM restarts. Okay? Usually, if you create an actor in Akka and your machine crashes, all the information is lost. And there are various ways how you can basically make sure that this information is not lost. And the Akka team created a project called Akka Persistence, where they basically do the event sourcing that I'm describing in this talk. And the mechanism that they have are persistent actors. So how does this look like? We again have our registration workflow. The user is entering his data on the website, is sending it to the web server is forwarding it to the controller. Then we have in the controller we're doing some kind of adaptation, right? Because we are mapping from some unstructured data to structured data to create this register command. And in Akka Persistence, what we usually have is a user manager. That would be the aggregate. Okay? And this aggregate is then basically looking at the message and decides what should it do with it. Should I don't know, look up a user, or should I create a user, should I delete a user, and so on. So the manager is basically the entrance, the security guy. And he's deciding which message goes back here and which one does not. And in our case, he's basically managing this list of emails that are already in our system. If he decides that we are accepting this command, what he does is he's creating a new user and sending this command to the user itself. Okay, this actor, like user 1 to user n, it's a persistent actor. And in this actor, we then handle the command that got sent to us. There we also have our event handlers and can do the stuff that we want to do in the case we got created. So we can send the welcome email, we can trigger the HTTP call to the external system that's creating the LDAP account, and so on. Okay? Important is that this stuff happens after, again, we persist the event to the event store. Then we invoke the event handlers, and of course we basically send back to the adapter that, okay, this user now got registered, and the adapter is connected with the controller and is communicating back to the user that everything worked well. How does such a manager or aggregate look like? Basically, it could look like this. A persistent actor always extends from persistent actor, not Akka actor, but persistent actor. And the thing that you need to do is to set a persistence ID. That's basically the entity ID that we had before when we looked at the short. Okay? So every persistent actor in our system, it has an ID. Because it's the manager, this is a static name. If it would be a user, we will take a look at this shortly, it will be dynamic. Okay? So we only have one user manager in our system, and what he has, a persistent actor always has two methods. It doesn't have the normal receive method, I mean it has it, but it's shadow, but it has two. It has receive command, that's the command handler, and it has receive recover, that's the event handler. So when this actor starts up, what is happening is all the events that are stored in the event journal, they get put, the receive recover method is invoked with all those messages in sequence. This actor is then updating internal state if it has some, like putting the email address and stuff. And only after this replaying of events is finished, new commands get processed. And that's also where you have some kind of consistency, because you cannot run into this situation where command comes in and the state is in flux. Okay? What you usually have, or at least I have, is a method that is like get or create child. Like you have an ID of an entity that you want to address, and either it's already in one of the childs you have in memory, or you create a new one. So when you're working with Akka, what you have is you always have tree-like structures. You have parents and then you have children. And those children, they can be parents of other ones, like the family tree. Okay? And depending on the state of your application, if it's a persistent actor, it can be already loaded, then it's in memory, then you have it as context or child, or it's not yet loaded and you basically create the actor. Okay? So, how does user actor basically look like? It's quite similar. We have here again some properties that we want to apply, and we extend from persistent actor. And here we see that the persistence ID, so the entity ID from the journal, it's dynamic. Why? Because it's user dash and then the ID that we gave the actor. Okay, so it's 1, 2, 3, 4, 5, depending on a sequence number that our user manager holds. And again, we have receive recover and receive command. In receive recover, we handle all the events that are stored in the journal, and after that happens, we have the receive command. Again, the command handler, he's basically checking the constraints, and what you usually do when you're now in a persistent actor is that after you store, in the previous example, where it was not Akka, we had this persist to journal. In Akka persistence, the method is just called persist. Okay? So persist is persist to journal. And what you have the same kind of programming, what you do is after this thing is persisted to the journal, you have this callback. And what I always do is that, okay, I have here now the events that are persisted, and I invoke my own receive recover method. In that way, I'm making sure that the state changes that are happening in my command handler are the same state changes that happen when this actor starts up. Because there are some people that they put the logic that should happen with this event here, and when they recover up, they have the receive recover method, and suddenly the actors are not in sync, but they are in an inconsistent state. They're depending on did this actor just load up from the database, or did it receive commands? They get into different states. So what I do is I always call the receive recover method and hand it the event. Okay. What we also can do is, for example, when we have this registered thing, we can tell the email actor that sent the welcome mail. And of course, the person who created us, in our case, is the manager actor. We tell them, okay, the user got now registered, and you can forward this to the person who wanted this to do. Receive command. Yeah. Of course, you can also put here various constraints that we cannot handle in the user manager. For example, here we're checking, okay, if the user wants to change his name, is it a different name than he had before? Okay? We cannot do this in the user manager because then we would have to store all the information about the actor twice, and we don't want to do that. So here we can also do sanity checks, and then again persist the event and invoke receive recover. And what I sometimes use for methods that usually would return void, I'm sending back the akka.done, and that's just a way of handling this case. Event handler is quite easy. In the receive recover, let's say we have the properties email and name. We just have a partial function again. We are interacting with those events and then just set the appropriate fields in our actor. Yeah, if we have many events, like let's say this actor changes, I don't know, every 5 minutes, then we would have really many events in the database genre. We still have those events in the genre, but usually we don't want to work on them because that would take a lot of time. So what we're doing is we're creating snapshots. And in a snapshot, what's happening is basically you calculate the state that's happening here till one point. Okay, and then what you do is let's say on the event number 1000, we take a snapshot and we just save the email and the name to the snapshot store, and the next time the actor is starting up, it's first looking at the snapshot store, sees, okay, at event 1000 I have a snapshot, and then it's basically restoring from that snapshot and then continuously playing with the remaining events. So if you have like 1010 events, basically you would read the snapshot and get the state at 1000, and just have to read 10 events instead of 1010. So that's quite an improvement of performance. Yeah, so if you're in this command handler, what you do is you basically just add another method and say maybe take a snapshot where you decide if you want to do that or not. Here we see how this is working for recovering. You again have your event handler, and if you get a snapshot, then this is encapsulated in a type called snapshot offer. It has some metadata and the snapshot payload, so you can recover from that. Yeah. If you have a really big system, it might not be possible to leave all the actors in memory. Because if you have like, I don't know, 20 million customers and everyone has first name, last name and whatever, you cannot leave this in the Java heap because you will run, you will get an out of memory exception. So what you should do in this case, or basically in all cases, is that you set a receive timeout. What is a receive timeout? It's almost clear from the name. If your actor does not receive a message in a certain time, like in this example 3 seconds, you will get a message of type receive timeout, and then you can act on that. For example, you could stop this actor, which would then generate a notification to its manager, and next time a message, so the actor gets garbage collected and the memory is free, and next time there's a request from this actor, it will get created new and the stuff will get loaded again from the database. A nice side effect from this is that basically this is a cache. So if you have certain types of actors and you specify that, okay, let's say I have a news site and I set the timeout to 20 seconds or something like this, or 10 seconds, and every time I hit the front page, this actor will get a message, so this one will always stay in memory till there's no new request to it. So you don't have to care about cache invalidation and stuff like that. It will always, as long as it's getting requests, it will always stay in memory and you have a cache for free. Good. Best practices. What you should always have is something called a protocol. A protocol is basically a defined way of interacting with your actor. What I always do is that I have at least events, commands, and queries. So for example, if I'm interacting with a user actor, I have an object user, I have inside that object I have events, and I have traits that form this, that qualify those case classes. How could this look like? For example, I have the events of my user, I then have case classes. A user created event, and that's extending the type event. And also the other ones, they are always extending the type event. And why I'm doing this, you will see now. Because with this, you get something not the same, but similar to what you have in Akka typed. Okay? Because what you can do now here is in your receive method, you say, okay, I'm gonna handle all messages of my event type, and IntelliJ is telling you all is generating all the case things, the case matches for you. And the other thing is that your compiler will tell you that you maybe forgot something. Yeah? If I forgot to implement a message type, the compiler will tell me. That's really cool. The same you do for commands and responses. What I also do is that for commands, depending on the use case I'm handling, I create also traits. So when I'm interacting with my actor and I'm sending him the create user command, then I know that I will get something back that's of type create user response, and again my IDE can create the match statements so I don't forget anything. Like I said, Akka type will be quite helpful, but till it's there, this is, in my opinion, the best thing you can do. Yeah, the same is with responses. What I have here is that I have all the kinds of queries and responses that they can do, and I have some object that's always the same. Like if I'm querying for a user and it's not here, then I have this case object user not found, and it's basically implementing all the traits where this case could happen. And then I can handle this in a central way before basically going down the other match statements. Okay. Other questions so far? Okay. CQRS, that's called Command Query Responsibility Segregation. What you basically do is that you split your applications into commands and queries. So, get information about the user is not a get user info command, it's a get user info query. Okay? So, commands are changing state, queries are just querying state. And you can divide your application not only in the actor way, but you can also divide it in deployables. So you could have a microservice that is handling all the commands, and you can have a microservice and many instances of that is handling all the queries. Okay, so you have one place where you're handling everything that is changing state, and you have another place where you handle everything that is just green. And this one you can scale out like crazy. So, CQRS example. Get the name of all the users in our system. There are different approaches on how to do this. The naive actor way would be to ask everyone and collect the answers. But we can do better than that. We could just read the event log, or what we can do is we can create custom read sites. So how does the ask everyone look like? Basically, we have actor that has a collection. The actor that gets created to handle this kind of query. And what does it get as parameters? He basically gets a list of all the IDs from the user in the system, and he gets a reference to our aggregate, to our user manager, and of course he needs to have a reference. Who should I tell the result when I'm done? Okay, so the easiest, what he's basically doing is he's iterating over all the IDs I have in my system and sending the aggregate the message, please get me the user info for user ID 5000 or something. Yeah? And the messages then go to the user actors, and one by one they come back to this get all names actors. This actor is then basically collecting all these answers, and when he got all the answers, he can send back to the actor that in the first place asked this question the answer. What you should of course also do is kind of set a receive timeout, so in case you don't get answers from everyone, that at one point you just tell the person, the actor that asked you, look, I have an incomplete result, but this is what I got so far. Okay, so in an actor-based system, usually you have some kind of what's it called? The weak consistency. Okay. What you can also do is use Akka persistence query. That's basically a way to read the event journal with Akka streams. depending on which journal you are using, for example Cassandra or Postgres and so on, the Cassandra journal and the Postgres journal, not the database, it's a slightly different to work on this. Okay? For example, the Cassandra regional is always pulling the journal for new changes, and that means you have a slight delay. But what you can do is, if you create this actor, then you're creating a new regional, and what I'm doing is that I have a method that's called start initial import, and basically I will show you now how this works. This is creating Akka stream, and when it's done, I'm mapping it to done. I'm piping then this basically to myself, so when I'm getting the done method, I know that there are no more events. How does this look like? Basically, if you have Akka stream, who knows Akka streams? Okay. What you basically have in an Akka stream is you always have a source. If you who knows SQL? Everyone, almost everyone. So in SQL you have select blah 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 from blah 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 where so and so. Okay. So a source in Akka streams is basically the from part. So I'm saying I'm selecting from this string or from this database table. Then you have the filter, that's basically the work part, where you filter out all the stuff you don't want. And in the end you have the map, that's basically the select, where you just take then the information that you really want. Okay, so let's look at how this is implemented here. Basically here we have the from, that's the all current IDs. What you have in Akka persistence is two different types of, or at least in this regional, two different types of sources. One is where you get the IDs that are now in the system, and one is a stream that it's not ending because there could be new events coming in the future. Okay, I'm usually reading from the one that we have now in the system, and it's just stopping at one point and then basically completing the future. And what you do is basically you're reading them. You have here basically your filter. Where I'm saying, okay, I'm only interested in events that start with user dash, because you always get all events in the journal. So they could also be for some completely different thing. So you're just skipping everything that's not related to the user, and yeah. And in the end, then here we could read then from another journal and just get everything that's related to this user. Yeah, you will get the slides online, so then you can take a deeper look into this. Yeah, but what we do here then in the end is basically to the actor ref that we got here, we send all the events that we read from this read journal and that are of interest to us. So basically we are filtering out all events that are not interested to us, and the rest one we send ourselves. And then we just have to aggregate those. So what we get from Akka streams, from Akka persistent streams, is an event envelope. You have some metadata and stuff here, but usually you're not interested in that. And of course you have the event in the end, and then it's just matching like normal. Okay, you fill the state like you want. And what I also did here is that when the consuming is done, we get this done message, and that's the time I know, okay, finally I can tell the actor that was asking me, this is the result. Okay, what you can also do is create a SQL read site. if you want to. Yeah, it's the same thing, but instead of storing it in the actor, you can do SQL queries and store it in an SQL database. If you're already using Akka streams, I will go through this actor way. I would directly connect the regional stream to a stream that is connected to the database, for example with Slick, because then you also get back pressure. Yeah. How to make this faster? Like I said, with the standard regional, at least for Cassandra, you have a delay of around 2 to 3 seconds. Depending on the application use case, this might be too long. What you can do to speed this up is that you can tag, you can create a write event adapter where you can tag every event with a tag. Usually that's in my case it's always the event name, and then you can just query all events in the journal with this tag. Okay? If you want it even faster, what you can do is you can publish those events to with the Akka event bus, and then the event handlers will get notified and you have the events almost instantly. Good. I think you have to speed up a little. Not a little, not a lot. Cluster Akka, there's an Akka cluster module. You can use cluster sharding to place aggregates on nodes. And I would then put all the child actors of those aggregates on the same node. I would not, it's in my opinion a bad practice to distribute child actors of aggregates to multiple nodes, because then you have a lot of network traffic. Yeah, you can use cluster singletons for read-side event handlers. Singletons so that you don't have multiple instances of them that will corrupt your, for example, your SQL database. And as a rule of thumb, the number of shard regions should be like approximately 10 times the amount of cluster nodes in your cluster. Clustering is Akka. Yeah, what you have is you still have your user manager, your aggregate, but what you also have is a region actor, and this region actor is then actually I have to think this region actor should be for here somewhere. But the region actor is basically responsible for forwarding the message that is coming in to the right cluster node, to the right shard region. Okay? Yeah. A great thing about Akka is that you have location transparency, so it doesn't really matter if the actor is on the current JVM or the JVM in another system. It's only taking longer and you can have message loss. But from the normal workflow, it doesn't matter if it's on the same computer. How do we create a shard region? Basically, we are using an Akka extension, in this case cluster sharding. What we do is we give the shard region a name, for example user. We telling that all actors that are in this shard region get created with this props object. We here have the default cluster sharding settings, and what you always have to do is provide 2 methods. One is extract entity ID, and the second one is extract shard ID. So those are methods that work on the message and extract somehow the information that is necessary to decide to which entity does this message belong, and in the follow-up saying to which shard do I need to send it. Yeah, how does it look different? The user manager now has a user region. The user manager should be a cluster singleton, like we said before. And what it does is basically is just taking all the messages and then forwards it to the corresponding user region. Yeah, that's, I mean, clustering in Akka is so much stuff, it would need another talk, so that's it for it now. I have now, I can give you my tips for structuring your project. So what I usually do is I have a project and a Docker image per bounded context. So this is all domain-driven design speaking, like aggregate, bounded context and so on. For example, I have one that's responsible for authenticating users, one that's responsible for managing users, one that is responsible for building users. What I then have is a root project that has a virtual host request handler. And why I have this? It's because in this way I can start all those applications on my local developer machine with standard SVT and use my local Play Framework app, but use host names. So in your etc hosts file, you put the host names that you want to use, and depending on which host name you enter in your browser, it gets routed to the right application. But when you deploy this to production, the SVT project is creating multiple Docker images that you can scale independently and so on. If you would want to optimize it even further, then you would have like out command and out query, but you can always decide this on a use case basis and how much load your system is handling. Okay. Yeah, what I do is I have my code structure is basically I have a package per entity, and in this users, and in this package I have a sub package which is basically per use case. So, or you can also say per command and query. So I have the use case that I want to create an owner. There I have my create owner controller. I have a service that's basically just the adapter between the controller and my Akka actor system. But of course, if I'm not using Akka persistence everywhere, because you don't need to use event sourcing everywhere, then this would be the facade for, I don't know, my Deos and whatever. And of course, I have here the input and output data types that my controller is using. So if my controller is taking data in JSON format, I have here the case classes that represent it, and also the case classes that are used for returning the answers to them. And I also have here the implicits that convert from JSON into JSON. So my implicits, they don't leak into lower abstractions. That's also helping with compiling speed. Yeah. So many of you hopefully know Venkat, and he once said that the most precious thing you can ask from someone is that it's not their money or the time, it's their attention. So thanks for still being with me and still being awake. I know it's late and I used way too much time, so thank you a lot. I have a blog with my name, Dominik.com. I have Twitter. If you want, you can add me on Xing or on LinkedIn. Yeah, if you're also interested in Java, every month, almost every month, we have the Java Vienna meetup. And I also have the Play Framework meetup. Please take some stickers. I made like 200 and we don't have so many members at the moment. So thankfully they don't get bad at home, but yeah, it would be great to see them on some laptops. Okay, yeah, thanks a lot. And you want, so we can discuss. But I also completely understand if you want to go home and just enjoy the rest of your